Let's begin. Exercise 2B. Make sure you have your notes ready. We're going to go through some notes on gradients. These are the questions. Even if you don't copy it, it's on Schoology. You've got your set questions there. But if you like, you can copy it down now. All right, but we're going to work in with gradient of a straight line. The equation of a straight line is exercise 2C. So I'll probably do that next session, which I don't see you tomorrow. Do I see you tomorrow? No, I don't. So I don't see you until next Thursday. Okay, next Friday.
Oh, it's the same point.
Yes, it's going to be a long time. So it's about a week. Okay, here we go. Let's do this. The 11s.
2B.
Thank you, 2B. All right, I'm going to try to describe this so that you got exercise 2A, 2B recorded, and I'll be doing C, D, E also recorded as well. So that way you're not missing too much next week, because I won't see you until next Friday. Okay, because Monday, Wednesday's out. Monday, Tuesday, Wednesday's out. So you won't see me until next Friday. So there's going to be a lot to take in. So make sure to listen, take some notes while you can, and then the videos, hopefully, I'm going to try to keep it detailed so that way you can be supported on the questions. I'll do the questions as well. Okay, so I'll do a couple of ones that I think is hard, and you can watch me do them if you found it difficult. I'll give you some so that you can do yourselves as well. Okay? All right, here we go. 2B. The gradient of a straight line. Let's recap that. Gradient of a straight line. What's a gradient mean again? Can I please have, let's go with Yasmin. What's a gradient? Rise over run. Okay, so rise over run. But at the end of the day, that still doesn't mean a lot to us. We say rise over run, drill that into our students, but all the way up to year 12, you still do the gradient. A lot of students don't know what rise over run means. So let's go back here. That's the definition. What is the gradient? You just told me rise over run, but if I went to your child and I said the gradient, rise over run, he will have no idea what you're talking about. What is the rise over run?
How much the height changes over a distance.
That is true. That is absolutely true. But let's speak more of a, like, imagine I was a 10-year-old and you're really trying to explain to me, besides saying as the height changes, as the distance moves. How would you describe it to me?
How steep it is.
How steep it is. Literally, how steep. You can teach a 10-year-old this. You can say, look, you can have a very steep mountain. Would you rather run up? Is it harder or is it easier? If it's flat or decline, which one would you rather run? Okay, they can sort of associate themselves with that. The gradient dictates, which is what you're saying, dictates how steep a line is or how flat a line is. Now, as you said, it depends on how much you rise, because the more you rise, think about a mountain, the steeper it is, it's harder to walk. You know, it's harder to walk up there, but if the ground is flat, that's much easier to walk. So the height is 0 at this point. If the height was any higher, let's say 2 meters, it's getting harder. If it's 3 meters, it's getting even harder. Okay? So what does that do? The height changes it and makes it steeper. Versus x values, if you increase the distance, if you have a look at this, that's what I'm really just trying to say. If you made the horizontal distance really far, so let's say you run 10 and you climb 1. See, if I draw these 2 points together, that's a very flat line compared to if I ran across 1, okay, and I went up 10. See the difference? So if I went up 10, this is very steep. If I ran 10 and went up 1, that's flatter. Okay, so the change in your y values versus your x values, what does it do? It changes the steepness of a straight line. That's what it does, and that's what we call the gradient. Okay, so the gradient is basically measuring what happens when you change y and what happens when you change x. Obviously, if the ratio is equal 10 to 10, it's normal. 45-degree angle. It's 5 to 5, 45-degree angle. It's 2 to 2, it's 45-degree angle. It's even, yeah. Just like that. 2 across, 2 up. 2 across, 2 up. It's like a stairs. It's consistent. But if you had something like this, if I told you to run 10 times and then step up 1 step, and then run 10 meters and then step up 1, it's not as difficult because every time you get up, it's just 1 step. But if I said the other way around, I said every time you run 1 meter, climb up 10 stairs, 1 meter, climb up 10 stairs, 10 stairs is going to be much more calorie burning than it is, well, it depends on how fast you run on 10 in that case, but you get what I mean. 10 kilometers. 10 meters. 10 kilometers and climb up 1 step. Okay, so that's what your gradient means. It just basically describes how steep a straight line is. Okay, now, a lot of us have been familiar since year 9, the formula. And And the reason why we're familiar with it, because all you're doing is you're finding out the distance, which is what you've been doing in your Pythagoras formula. You're finding out how far horizontally it is and how far vertically it is. So all I'm doing here is I'm just saying all the x values find the distance. All the y values find the distance. That's all you're doing. So if you knew this was 3 to 5, then you know the distance is 2. How did you know the distance is 2? 5 take away 3. Yeah, so that's all they're doing here. 5 take away 3, and whatever the vertical distance is. That tells you rise over run. Most of us would have picked up on this. Year 9, year 10, we would have done that. The only one new thing is adding in angles, and I'm going to get to that, okay? But for now, let's do some examples, okay? So, let's have a look. It does not matter which point. No, okay, cool. We all know that one. Here we go. Let's have a look at this. I'm going to do about probably 4 or 5 different examples here. Let's have a look at this. It says, find the gradient of each line. Gradient means the steepness. The steepness of each line depends on how much you rise and how much you run. But remember, you're choosing it between 2 points. Now you can use any 2 points on that line. I'm using this point to this point. I know this coordinate here is -2, 0. I know this coordinate here is 0, 2. According to your formula, you learnt that gradient is rise over run, which horizontally, we can say from -2 all the way up to this coordinate here. How far is that? 2. Yeah, from -2 to 0, that's a distance of 2. But how did you know that? You can actually just write it mathematically. You can say, I knew it was 2 because -2 take away 0 is that -2. Now, I know that negative doesn't seem to make sense here, but I'm going to show you. Okay, vertically, what's the distance? You went from 0 to 2. So that distance now, if you work it out, you did -2 take away 0, then it'll now be 0 take away 2. That now works out to be -2 over -2, and -2 divided by -2 is 1. Okay? And that's really just saying that you have a gradient of 1. But what does a gradient of 1 mean? So a gradient of 1, you got to understand again, it just means it's the measurement of how much you move across and how much you move up and down. Now, if I were to write 1 as a fraction, how do I write 1 as a fraction? 1 over 1, not 1, 0. 1 over 0 makes it undefined. Now, 1 over 1 means 1 divided by 1. We all know 1 divided by 1 is 1. So I just wrote 1 as a whole number. It's 1 out of 1. Now, what does this mean when you say 1 out of 1?
It means 1.
No, rise and run. Rise and run, this means every time you move across 1, so horizontally 1, you move vertically 1. And that's what is happening here. So if I show you the steps that is actually moving here. So from -2, if I move across 1, so that's a distance of 1, I move up 1. And then if I move across 1 again, and I move up 1, I land here. See, that's what a gradient is. You're consistently following this ratio. 1 across, 1 up, 1 across, 1 up, 1 across, 1 up. That's what a gradient means. Okay, so it could have been 2 across, 2 up. Okay, because it's 1 across, 1 up, 2 across, 2 up, 3 across, 3 up. It's the same ratio. It's like saying 1 to 1, 2 to 2, 3 to 3. They're all the same thing. They're all moving at the same rate, which is what, sorry, what was your name? Ben was saying how much you move and how much you go across, up and across, that's what a ratio is, and that's what a gradient means. And that's where the confusing part is in year 12. A lot of students find the rate ratios hard to understand. Okay, because a lot of us, we're not used to the fractions, we're not used to ratios. It's not something we like. That's why it gets confusing. Okay, but the logic behind it, all you're really saying is it's the steepness of a line. Okay. Now, we will say this is a gradient of 1. Okay, so I'm going to write here gradient of 1. I'll write over here m equals to 1. Now, let's do the next one. Second one. In year 9, year 10, when you're finding out the gradient, you'll be picking 2 points. Now, just conveniently, I can see there's a corner right here, there's a corner right there that I can pick. So I'm going to pick 2 points. I'm going to pick again. This is now 0, 3, and this is your second point that you know is at 2, 0. So if I asked you to find the gradient, if you know you had 0, 3, and 2, 0, using your formula, as you said, it was y2 minus y1 over x2 minus x1. So let's work that out. if this is my x1, y1, and this is my x2, y2, then all you're doing is you're just plugging in the values to the formula. You're just finding vertical distance. You went from 3 to 0. It's down 3. Okay, so you're losing 3. And then 0 to 2, you're going across by 2. Okay, but you can work it out mathematically. You can write it down and say that is just y2 minus y1, which is 0 minus 3, over x2, which is 2, minus 0. And what that gives me now is I've got negative 3 over 2. This is my gradient. What does this mean? It's all about what it means. I don't care about the answer. I'm more interested in what does it mean when you say negative 3 on 2? What does it mean when you say negative 3 on 2?
You go across 2, you go down.
Fantastic. Literally, that's what it means. It literally just means, this is your rise over run. It just means 2 across. So moving 2 across, instead of going up, which is what you're used to, rise over run, that negative tells you the opposite direction. So now you're going down 3.
So every time you go down 3, you essentially
Yeah, and that's exactly what's happening here. So you see from this point, you went down 3, you went 1, 2, 3. So 3 take away 3 goes down to 0, and you go across 2. 1, 2. That's what you're doing. So you want to get to the next point, go down 3, across 2. 1, 2, get to the next point, down 3, across 2. Okay, that's what this ratio means. It just tells you how much you go vertically, how much you go horizontally. Okay. Now let's revise. I'm going to write here m equals to negative 3 on 2. In year 9, you learned there are 4 types of gradients. I just showed you 2. This is a positive answer, positive 1. So it's positive gradient, which looks like it's going up. This is a negative 3 on 2. It's a negative gradient, so it looks like it's going down. What's the other 2? You got a positive, you got a negative. What else am I missing?
we can't find the answer.
When you can't find the answer? Good.
It's like vertical.
Why is it vertical?
Because, no, it's...
So you're right, there are 2 points.
Because there's no denominator.
Fantastic. The 2 answers that you're talking about, when you're drawing a straight line, you can have a horizontal and a vertical, which is one of them is undefined and the other one's called? Zero gradient. And you don't have to memorize all this because it all makes sense. If I drew a vertical line right now, so let's say, actually, I wonder if I have the graph. Do I have a graph of it? Let's see. No graph? No, no graph. Okay, I'll draw it myself. So, if I drew a graph here and I said this was 3, and I asked you to find the gradient between 2 points. Let's say I gave you this point and this point. So that's 1, so that's 1, 3 at 0, 3. If I asked you to find the gradient of a horizontal line, you would say, this is y2 minus y1 over x2 minus x1. Yeah, so you use the same formula as I had before. If you were to work out the gradient of this line, it'd work out to be 0. That's why it's called a 0 gradient. You see, if I did m equals 2, now this is y2 and this is y1, then I'd do 3 take away 3 over, this is 1 take away 0, and what you can see is that becomes 0 over 1, 0 divided by 1, 0. If you had $0 and you want to share it to one person, of course they're going to get $0. Yeah? That's why we call that the 0 gradient. So a horizontal line is the 0 gradient. What about a vertical line? So we try a vertical line now. So with a vertical line, I'm just going to rub this one off here. If we do a vertical line, let's say at 2, so I got 2, 0, and let's make another point. Let's say that's 2, 1. So the question is, why is this called an undefined line? Well, let's figure it out. y2 minus y1, x2 minus x1. So if you do that, you got 0 take away 1 and 2 take away 2. So let's work that out. You got 0 take away 1 and 2 take away 2. What this works out to be is you got negative 1 on 0. A lot of students would tell me that answer is 0 because you're not familiar with the undefined. If you think about it, you can't actually answer this question. You got, let's just change that answer to be a positive 1, for example. You had $1, but you don't know who you're going to share it to. Oh. Huh. Okay. If you had $1 and you didn't know who you're going to share it to, it makes sense that your answer is, I don't know how much I'm going to share it by. True? If you didn't have anyone to share it to, if I had $0 and I knew I had one friend to share it to, you know that definite one thing is that one friend is going to get $0. If I had $0 and I said, Brian, I want to share you my money, it's very clear he's going to get 0 because I've got nothing. But then if I had $1 and Ryan's like, are you going to share me part of that money? I'm like, I don't know. I don't know who I'm going to give it to. He doesn't get an answer. He doesn't know how much he's going to get. He doesn't know if I'm going to give it to him or not. It's not defined. That's why when you divide by 0, it doesn't matter how much you have. It doesn't matter how much money you have. You're going to have $100,000 here. But you don't know who you're going to give it to. The answer is always unknown. You don't know the answer.
So what do you do? What do you write?
Undefined. Question mark. Yeah. You can't even do it in your calculator. If you type in your calculator, it says syntax error. Because we don't know the answer. So hence why this is called your undefined line. Okay, so undefined gradient is your vertical. It only happens when you do a vertical line. Okay, so you only got 4 gradients to revise there. Positive, negative, 0, undefined. But they all follow one formula. That's all it is.
Oh, it just seems like you could also make it infinite because the more you go up, but then it will never actually reaches. So
whenever I think of 45 degrees, I just think of angles of this. More than this. When I technically, yes, this is 45. Yes, that's whatever plus
Yes, exactly. All right, excellent. Let's go to this one now. I want you to do example 4 for me. Copy this one down in your exercise books. Let's go. I want you to find the gradient of that line. Let's go. You've got one formula I just gave you. Find out the gradient of this line for me, please. Let's go. Gradient of this line. y2 minus y1 of x2 minus x1. It's your gradient form. That's the only one thing I taught for 2B so far.
7 minus 6.
There'll be more for you to take in. Remember, it doesn't matter which corner you choose as y2, you can choose any of them. It doesn't matter. If it's a ratio, it doesn't matter which one you choose.
The gradient can be negative, right?
The gradient can be negative. You've got 4 types of gradient. Positive, negative, negative, negative. 0 is negative 1 over negative.
What's negative 3 minus 1? What's negative 3 minus 1?
Is that what he got?
technically you should see
Is it negative 3 minus 1 negative 4? Negative 4.
Negative 4 over 1.
Negative 3 minus 1. What is it? I don't know.
Let's visualize it. Yeah, I've drawn the picture for you as well.
No, it's 1 over negative 4.
Yeah, that's definitely
1 to 6, negative 3, 7. Yeah, it wasn't 1, right? Does that look like a negative gradient, positive gradient, undefined, or 0 gradient? Positive. So you should be looking for a positive gradient. Did you? We're going to find out this. That's what I got too.
Oh, that makes sense. So we
7 take away 6. So you did 7 take away 6. That's correct. And then you did negative 3 take away 1.
Yes, that's what I got. Wait, so let's look with negative 3 and 7 is 7 is like negative 7.
Oh, you're right.
Yeah.
It's all the way around.
I wrote negative 3, 7 here, but that's a negative 7 there. It should actually be up here.
Yeah.
Well, what's my answer then? Let me just check.
Wait, how is that a gradient?
Oh, thank God I got the right answer.
Wait, what's the answer?
The gradient of the fraction is the only thing going. It just means 1 across, 1 down.
Wait, why do you
It's just mathematically because
No, what do you have then? No, not what you have. What do you
But if you take a negative away from negative, check your answers. Notice that I chose
it's negative 1 over 4.
negative 1 over 4, yeah. Negative a quarter. Notice, in both cases, it doesn't matter which number you choose.
Not -1, it's like negative.
It still ends up being the same. So if I did 6 take away -3, I mean sorry, 6 take away 7, 1 take away -3, it ends up being the same. So it doesn't matter which way you do it. Either coordinates are fine, they end up with the same answer. Be careful with the brackets. Putting brackets, be careful with negatives. I drew the diagram wrong, by the way. It should be the other way. It should be like that. -3, 7. This is wrong. I'll fix that. How do we feel? Pretty good with gradients? Yeah? All right. Here's the hard part. Copy this one down, so pay attention. All right, I've got 15 minutes to hopefully make this make sense to you. Okay, so let's have a look at this. This is the only part that's new for the year 11 course that you haven't learnt, or you may have if you did the apps class. From year 10, listening? Thank you. From year 10, you learned trigonometric ratios, so sine, cos, tan. One of the things you knew is in a triangle, a right angle triangle, if you have the angle theta, you can label the sides, right? Now, if I were to label tan, tan is opposite over adjacent. Now, which side, if I call this 3, 2, and 1, which one's my opposite side? What number? 2. That's my opposite. So I'm going to write here 2 is my opposite. And if I said which one is my adjacent? 1. So I write here adjacent. Now what you can see, this is very similar to what you were just doing just now. Gradient was rise over run. Tan is opposite over adjacent. So when you write tan theta, it's a ratio, it's a fraction, just the same as a gradient, which is why when you actually do, whoops, I just wrote this off here, opposite over adjacent, when you actually write it out, this is rise and that's run. So technically, if you say that m, which is a gradient, is your y values over your x values, so rise divided by run, or y2 minus y1 over x2 minus x1. That's the same thing as saying y2 minus y1 is your opposite, the length of the opposite. x2 minus x1 just tells us the length of your adjacent. Opposite of adjacent is the same thing as tan.
The gradient is actually the
tan of an angle. Yes. So when you type in your calculator, if you did tan of 45 degrees, yeah? That should give you an answer, and I think that answer is 1. Okay? Because it makes sense. If it's 45-degree triangle, if this is 45 degrees, that's a right angle, and that's 45 degrees, it makes sense that this side and this side are the same. Okay? So I know, because it's the same ratio, it has to be a 1-to-1 ratio. Okay? Hence why it's 1. So tan of theta, what I'm trying to say here, this is the only new information that gets tricky, is tan of an angle is the same thing as finding out the gradient, which means the steepness of this line. Okay? So that angle can change. It could be like 90 degrees, which makes it right angle, and it's vertical. Or it could be 30 degrees, and it comes out a bit flatter. Okay, so the angle can change. If you think about it, I can do this angle here, I can do this angle here, I can do this angle here. That will change the steepness of the line. Okay, so that's what we're saying. We're saying tan of theta tells you the ratio for your gradient. Okay, so let's do an example so you can get a feel of how to use this. Let's take this example. That's a read. I got 10 minutes left. Determine the gradient of the line passing through the points 3, 2, 5, 7, and the angle that the line makes with the positive direction of the x-axis. I know it's quite a mouthful there, but all they're really trying to say to you is this. If you had a graph 3, 2, 3, 2, so that's 3, 2, 5, 7, so let's say that's 5, and this is 4, 6, so maybe 7's up here a bit. 7, 5, 7. They're just saying, find the angle that this line makes with the positive direction of the x-axis. This is the positive direction. What angle does it make with that line? The positive direction. That's negative direction. So this is on the negative side. the positive side. So all they're asking is, they're saying, find out what this angle is. I'm going to color in blue. That's the positive direction. They're asking, what's that angle? That's what the question's asking here. It says, find the angle that the line makes with the positive direction of the x-axis. Okay, so this is the positive direction. That's with the line. So what's the angle that it makes with the line? Okay, so that's the angle we want to find. Now what you can see is I can draw out my triangle here. See, this triangle should have the same angle as this angle. So if you think about it, it's like your parallel lines back then. So parallel lines, if you remember back in year 7, if I talked about this angle here, it's the same as that angle there. Yeah, so that's why this angle here is the same as this angle here. They're both the same. Both lie on the same line. These two are parallel. So that's why this angle here and this angle here are the same. Just like this angle here and this angle here are the same. These are called corresponding angles. Okay? So all they're trying to ask you to do is find this angle. To find that angle, you can use this triangle here that you have. You got the distance horizontally. You got the distance vertically. Okay, you know that this is 7. That's how high it is, and it goes up to from 2 to 7, distance of 5. 3 to 5, distance of 2. So if I draw out my triangle, again, I'm just saying I went from 2 to 7, and over here I went from 3 to 5. So you know the distance is 2, distance is 5. How do you find out the gradient? Clearly, the gradient is rise 5 and across 2. Yes? Yep. Okay, so you know that the gradient is rise 5 across 2. So what I'm going to do here is going to quickly show you how I would have done this question. To find the gradient, you can just do y2 minus y1, 7, take away 2, y2 minus y1, x2 minus x1, 5 take away 3. Work that out. That now gives you 5 on 2. Exactly the same thing as I just told you. I just said 3 to 5 is 2, 2 to 7, 5. But we still haven't answered the question. We said we want to find the angle that it makes. I still don't know what this is. But I do know m. We already know tan theta equals to m. So if you write it out, tan of theta has to equal to 512. To find out angle, remove the tan. How do you remove tan again? Inverse tan. So theta equals to inverse tan. 512. Type it in your calculator. And that should tell you the answer. Okay, so inverse tan. Alright, I'm going to pause it there. But that's where I want you to sort of understand up to. Okay, the new thing is tan of theta equals to the gradient. That's your new thing to learn. That's your new thing to sort of work with. But we'll pause it there. And you guys you got about 8 minutes left to try to understand that. Okay, but I'm going to pause the video now. I'm going to pause the video.